With the rising human population, there is urgent need to safeguard and deliver food production at a time where natural resources are running out. We must ensure that this is done sustainably and without adverse effects on our environment. In particular, we need to protect our water resources, which are currently threatened by environmental pollution. In this context, we suggest that agriculture can provide the solutions if we can develop circular systems that produce food and at the same time protect our environment.
My name is Professor Marcel Jansen from UCC in Cork, and I'd like to talk to you about the circular economy and Lemna. The circular economy is a very popular concept, so what's it all about? It's about reusing, recycling. So an economy where we reuse and recycle demands much less resources, much less mining, for instance. And it produces much less waste, because waste is the new resource. What we do in the Brainwaves project is we look at waste from the farming industry, from the food processing industry, and we treat it as a new resource. And the way we do that is with this very special plant. It's duckweed. In a way, it's a very common plant spread much of the world. It has two very specific characteristics. First of all, it can grow on contaminated wastewaters, taking out those resources. And then it creates something very valuable, and that is biomass, which is very high in protein. And not just any protein, but in really good proteins. It's actually quite comparable with soybean and can then be used in feeds, but also human food. So what you will hear next is two ways that Brainwave is developing technology to grow duckweed on waste. We'll first hear about outdoor growth systems and then about indoor bioreactors.
Our aim via Brainwaves is to develop effective and efficient systems that can process agricultural waste and at the same time produce valuable biomass. This will be an outdoor system that aims to be functional for the majority of the year. Using interconnected ponds, we can extract nutrients and clean waste, mitigating impacts on our environment.
Hello, I'm Dr. Neil Coughlin. I'm a postdoctoral researcher at the School of Bees UCC. So this is one of our duckweed bioreactors. It's a pilot system operating at 125 litres. Within it, we grow duckweed on a 7-day cycle to assess the plant's ability to grow under different operational parameters. These parameters would include different flow rates, water depths, harvesting regimes, and surface cover densities. Ultimately, we wish to determine the combination of parameters that deliver optimal bioreactor performance in relation to duckweed's biomass generation, their protein content, and their ability to remediate wastewater.
Hi, I'm Anna Power. I'm the project manager on Brainwaves. We're currently looking for engineering, LED and water quality companies who might be interested in collaborating with us on the development, design and operation of our duckweed systems. We're also looking for farmers, the end users, who might be interested in hosting a demonstration duckweed system on their own farms. If you'd like to find out more, please visit our website ucc.ie/brainwaves.
Brainwaves is a collaboration between University College Cork and Aberystwyth University. We are funded through the European Regional Development Fund Ireland Wales programme, administered by the Welsh European Funding Office. The project can work with eligible businesses in the areas of South East Ireland and West Wales, as shown in yellow on the map.